Hello, this is Mr. Stansbury. I'm going to take you through some of the problems on the 6B assignment. Okay, so first one we're going to start with is number 1. Find the surface area of each rectangular prism. So really the surface area on this here is you've got the right and the left side are the same, so right and left, and then the top and the bottom are the same, top and bottom, and then the front and the back and bottom. Okay, those are the same. Okay, so basically once you find either, like we can find the right, the top, and the front, and then just take all those and multiply them by 2, right? So we do 2 times each one of what we find, right? And then we will add those all up for our total surface area. Okay, so let's see, right and left. So this right side right here is 1.43 times 0.92. So right and left, 1.43 times 0.92. And then say the top and the bottom is going to be 0.67 times 0.92. And then the front here is 0.67 by 1.43. Right, and that's front and back. Okay, so we can calculate each of those. 1.43 times 0.92 gives us let's go maybe out to 3 decimals, 1.316. That's in here, 1.316, and then we can do 0.67 times 0.92, and that gives us 0.616, 0.616, and then we can do 0.67 times 1.43. 0.67 times 1.43, and that gives us 0.958. 0.958, right? Okay, so now possibly even an easier way of doing this is going to be, let's not even do the doubles yet. Let's do 1.316 plus 0.616 plus 0.958, and then we will take that and add those all up and then double that, and that will equal our surface area. Okay, so let's try that out. 1.316 plus 0.616 plus 0.958, and that gives us 2.89, and we double that, so times 2, and so our total surface area is 5.78, and it's meters. Since we're talking about area, it's meters squared. Okay, let's look at next one, number 2. Find the surface area of each triangular prism. So let's see, we're gonna have, the front and the back are the same, front and back. That will give us one. Let's see, we've got the right side, but there's nothing else that's similar to the right side. We also have the top, but nothing else is similar to the top. And then we have the, kind of the slanted bottom piece here. Okay, so we really kind of have to figure out each piece individually. In the front and the back, this and this are going to be the same, so we can just double those instead of recalculating. So front and back, that's a triangle, so it's going to be 1/2 of 10 times 6, which is going to give us, what, half of 60 is 30. So 2 times 30 gives us 60 square meters here. The right side here is 6 times 12, which is going to give us 72 square meters. The top here is 10 by 12, 120 square meters. And then this piece right here, we know that this depth right here is 12, but what we have to do is we have to figure out what this is. They don't give us that, but we can find that with good old a squared plus b squared equals c squared, right? So this is 10, this is 6, so we would do 10 squared plus 6 squared equals c squared. 100 plus 36 is c squared, so whatever 136 is, square root both sides of that, and we get that c will have to be the square root of 136, which is 11 point, let's go with 11.7. Okay, so this is 11.7. So this big flat side under here, right, this piece right here, that's going to be 11.7 times 12. Oops. Let's keep consistent, times 12. So 11.7 times 12 gives us 140.4. Okay, and then we add those all up, and that is what our total surface area is going to be. Plus 60, plus 72, plus 120, and we get 392.4 square meters would be our surface area for that one there. Okay? Okay. Moving on, number 3. Draw each solid and hence find its surface area. A block of cheese, measuring, so forth and so on. So let's see. It doesn't matter. We can draw this however we want. So I'm going to draw this 14 high, 8 wide. So I have this nice big rectangle here. I'm not going to grade you on your 3D dimension drawing yet. So this is 14. This here is 8, and then 3 centimeters deep. So then what we'd like to do there is just draw these little lines here like so. And then we connect those. We call this 3 centimeters, and that's our block. And if we want to do our little 3D drawing, we would do that if you want to. You don't have to, but okay. So find the surface area. That's going to be, again, we got to, like the top and the bottom, the front and the back, and the left and right are all going to be the same. So let's find the sides, top and bottom, front and back, right? So we'll find each of those, and we'll add them all up, and we'll double them because each one of those has 2, and that will be our total surface area, okay? So the sides here, let's see, that's going to be 14 by 8. So let's do, I'm going to get rid of some of this stuff here, and we'll add that up later. Okay. So sides are 14 times 8. Top here is 3 by 8. And then the front here is, oh, oops, I did the wrong for the sides. That's 14 times 3, because then the front and back is going to be 14 times 8. Right? Because the front here is 14 by 8. All right? We multiply those out. Add those all up. Let's see. 14 times 3 is 42. And then 14 times 8 is 112. So we add those all up. We get 178. But again, that's just half of it, right? Because that's the front, top, and bottom. Front, top, and side. So then we have to double that to get our total surface area. So we take that times 2, and we get, oops. What? Oh, sorry, I wasn't. 178 times 2 gives us 356 centimeters squared there. Okay, moving on to number 4. Find the surface area of each pyramid. Okay, so important to note is that this is a square base here, so that means all these triangles here are all going to be the same area. So what we want to do is we want to find the base. Oops. We want to find the base. And then we want to find the sides. And we're going to multiply those by 4, right? Because, again, each one of these sides is going to be the same. So let's see. The area of the base is just going to be 20 times 20, which is 400 centimeters squared. The area of one of the sides is going to, remember, the area of a triangle is 1/2 the base times the height. Since this is 20, this is going to be 20. So if we simply draw one of the triangle sides on their own, it's going to look like this, right? 20 by, and this is 26. So the area of this thing is going to equal 1/2 20 times 26, right? So half of 20 just gives us 10, right? So 10 times 26 is going to be 260. So this is going to equal 260 centimeters squared for 1, but then we have to multiply that by 4, and that's going to give us what? 1020 centimeters squared plus 400 centimeters squared for the base to give us 1,420 centimeters squared for that one. Be 410. This would be 1040, so this is going to be 1440. That's what I meant. All right. Moving on. Next part here. Now we've got some round shapes instead of all just flat-sided shapes. Now we've got some round shapes. But again, there's some nice formulas for these, so that should excuse me, that should help out. Find a 1 decimal place the outer surface area of these here. So now we have a hollow cylinder, a hollow can, and a solid cylinder. So here's what I would do. I would assume, unless they say that it's hollow, I would assume that that's a top and that's a bottom right there. Okay, so let's go with this one here. So the area on this one is going to be 2 times pi times the radius, which the radius is 8, times the height, which is 12, plus 2 times pi times our radius, again, which is 8 squared. Okay? And so we literally just have the formula here, and we're just going to plug everything in, and away we go. So 2 times pi times 8 times 12 plus 2 times pi times 8 squared. Okay, so we should be able to just put that all in at once, and we get 1,005.3. And that is going to be centimeters, since it's area, centimeters squared. Okay? Okay. For C here, it tells us that it's a hollow cone, so we're going to use this one right here. And again, over here we use this one. So our area is going to equal pi times our radius, which is 6 here, times S. Okay, now, it doesn't specify right in here. I think it'll say on your formula sheet, but the S is slant height. Okay, which is this 10 right here. Okay, it's not the regular H. If it was H, it would be this piece right here, but it's asking for S, so it's the slant height. So we're lucky because they actually gave it to us. So we just do that times 10 there, and we just calculate, and away we go. So we've got pi times 6 times 10, right, which gives us 188.5. is going to be our area, and that is centimeters squared. Okay? Okay. Moving on to, let's see, number 4 here. A new wharf has 24 cylindrical concrete pylons, each with diameter 0.6 meters and length 10 meters. Pylons will be coated with salt-resistant material. Find the total surface area of one pylon. So here's our formula, which I didn't quite fit all the way on there. So let's just move that over like this. So the pylon is going to be solid, so we're going to want to use this here. So our area is of one of those is going to be 2 times pi times our radius. Now that's going to be half of 6, right? Radius is going to be 0.6 divided by 2, which is 0.3. 0.3 times our height, which is 10 meters. One thing that you kind of got to be careful with on these is make sure that these the units of measure always match. If they don't, you're going to have to convert one or the other to match the other one. Okay, but this one, again, we're okay with. Plus 2 times pi times our radius, which was 0.3 squared. Okay, and then we just put that into the calculator and calculate, and we're good. Here it all is entered into the calculator. We push enter. 19.4. Surface area is 19.4 square meters for this part here. Part B, coating the pylons with material costs $45.50 per square meter. Find the cost of coating one pylon. So 19.4 meters squared times 45.50. 19.4. So this was part A. This is part B. 19.4 times 45.5 will give us our total dollar amount, won't it? Okay, so 19.4 times 45.5 gives us 882.7. Now we wouldn't want to write 0.7, we would want to write 0.70 for the $882.70. Okay? All right, height of hollow cylinder is the same as its diameter. Okay, so write an expression for the outer surface area of the cylinder in terms of its radius r. So that means if this is the radius, the diameter is the same as the height. So that would be 2r for the height, right? And it says it's hollow, so we're going to use this one here. So our area, this is part A, is going to equal 2 times pi times our radius, which is just r, times our height, which is 2r. So 2 times 2 is 4 pi. R times r is r squared. So the area of this thing is going to be 4 pi r squared. Okay, and then part B says find the height of the cylinder if the surface area is 91.6 meters squared. So our surface area, these are really SA, surface area. So our surface area is 91.6. Now we know that's going to have to equal 4 pi r squared. So now we can divide both sides by 4 pi. Right? And that will tell us what the r squared is. So super important when you are dividing by more than one thing. You want to do one of two things. Here's what I'm going to suggest that you do. 91.6 divide by, do parentheses so that you get both pieces in there. 4 and then pi. Because now 91.6 will divide by both 4 and pi. Okay. If we did 91.6 divided by 4, if we do 4 pi, it might still work. It doesn't work. Look, so what it does is takes 91.6, divides it by 4, and then multiplies it by pi. So we don't want to do that. We want to that's why you want to put everything in parentheses in the denominator there. So 7.29 we'll go with is the radius squared. So we square root both sides to get that our radius is, oops, that's not what I wanted. Square root of our answer gives us 8.5, we'll call it, is the radius, but it says find the height. The height is 2 radii, so the height will equal 2 times 8.5. So the height will be, what, about 17 meters. All right, next one we have, number 11. Find correct to 1 decimal place the surface area of each solid here. So, look, we've got a cone and a cylinder, half a semi-sphere on top of that, basically like a little ice cream cone. Okay, so what we want to do is we are going to have just the hollow cone, and then this like half of the sphere, so hemisphere, right? So we are going to add those two pieces together. So we're going to have this here. So the area on this thing is going to equal pi times r times s plus 1/2. This is the surface area, sorry, 1/2 of 4 times pi times the radius squared. Okay, because that's this one here, but it's only half of it, so we would, that's why, hence the 1/2. Okay, so let's plug in what we know. Surface area equals pi times our radius is 2. S is the slant height. It's nice, they give us the slant height. Sometimes they don't. Sometimes they'll give you the actual height, and you have to do a squared plus b squared equals c squared, but they gave that to us, so we're good. 1/2 of 4 times pi times our radius, which is 2 squared, and that's, we can really just enter this whole thing in, and away we go. Okay, so here we have that. We get 62.8 centimeters squared. Okay, and then one last one to go over is number 12. The planet Neptune is roughly spherical and has surface area 7.618 times 10 to the 9th kilometers squared. Estimate the radius of Neptune. So again, there's our formula. 4 pi r squared for the surface area of our sphere here. So now it tells us that the surface area is 7.618 times 10 to the 9th, and that's going to equal 4 times pi times our radius squared, right? So what we really want to do is we want to divide first both sides by 4 pi, right? So we get rid of those and we end up with r squared equals. So let's see what we can do about this scientific notation here. So really we can just do this, 7.618, and we can simply just do this times 10 to the 9th, right? And there's our scientific notation, basically just moving that decimal over 9 spots to the right. And then we want to divide that by parentheses 4 pi. If you don't put the parentheses in there, it's going to give you a wrong answer by about a factor of 10. Okay, so we end up with 606221178. 22178 something. So to get the actual radius, we want to square root both sides. So on here, we would simply just do second square root and then second answer. We'll put this number back in so we don't have to retype it in, and we get 24,621.5. So let's go 24,622. And that's kilometers. That's a pretty big radius. Okay. All right, that's all we have for the 6B assignment. If you have any questions on this or anything else, please feel free to ask. Thanks.